The weight ratio of the component of the miscible blend is 30 to 70. So the weight fraction of component A is equal to WA is equal to 0.3, and weight fraction of component B WB is equal to 0.7. Given that the glass transition temperature of component A, is equal to minus 50 degrees centigrade. Here remember always temperature taken in the Kelvin. So degree centigrade is converted in Kelvin by adding the 273 in given data plus 273 is equal to 223 Kelvin, and glass transition temperature of component B is equal to 100 degrees centigrade. Converted into the Kelvin, then you get 100 plus 273 is equal to 373 Kelvin. Now the glass transition temperature of the miscible blend is calculated by the following formula: 1 upon Tg is equal to weight fraction of A divided by glass transition temperature of A plus weight fraction of B divided by glass transition temperature of component B. Then the 1 upon Tg is equal to weight fraction of A given by 0.3, and glass transition temperature of T component A is 2 to 3 plus 0.7 divided by 373. Then the glass transition temperature of the miscible blend is equal to 373 into 223 divided by 0.3 into 373 plus 0.7 into 223. After the calculation, you get glass transition temperature is equal to 310.6 Kelvin. Then this temperature in the Kelvin, so converted into the degree centigrade by subtracting 273 and minus 273. Then the glass transition temperature of the miscible blend is equal to 37.6 degrees centigrade. Understand what is the 3-point loading? In 3-point loading is tested by the UTM, universal testing machine, in which two cantilever beam given at a sample is placed on the beam, and at the midpoint of the sample apply the force load, and you see the sample start bending like this. Then the strength of the material required to resist this bending is known as the flexural strength. The flexural strength are the two types. The flexural strength. If the sample is taken in the rectangular cross section in the rectangular cross section, in that case the flexural strength is equal to 3P into L divided by 2 into B into D square, where P is equal to applied load, L is equal to specimen length, D is equal to width of the specimen, and D is equal to thickness, and where the circular cross section, in that case the flexural strength is given by P into L divided by pi into RQ, where L is equal to length of specimen, P is equal to applied load, and R is equal to radius of the cross section. Then in question number 13, given that the rectangular bar of the length specimen L0 is equal to 3 cm, depth In question number 13, given that the applied load at the midpoint of the specimen P is equal to 80 kg and width of the specimen B is equal to width of specimen is equal to 3 centimeter and depth of specimen या thickness D is equal to 2 centimeter and the length of specimen L naught is equal to 30 centimeter. Now using the for the rectangular bar, the sigma F is equal to 3P into L divided by 2B into D square. Put all these value in SI unit. Then 3 into 80 into G की value 9.81. This is the known as force. And the length 0.3 meter divided by 0.3 into 0.03 का whole 0.03 into 0.02 का whole square. Then you get flexural strength is equal to 29.43 megapascal. Initially, a ball is placed at height of 10 meter from the ground, and ball is the free fall from the height of the 10 meter and collided with surface of the ground. Due to the collision of ball with the surface, it lost some energy, and that's why it will be never return its initial position. So after the rebound, it get the new position S2 is equal to 8 meter. See, here is the some loss of the height. Then loss of height is equal to delta H is equal to H1 minus H2. 10 minus 8 is equal to 2 meter. So the loss of energy is equal to loss of energy is equal to M into G into change in length. In the question given that mass of the ball is equal to 100 gram, that means 0.1 kg into, and G is equal to 9.8 and delta H is equal to 2. Then you get 1.96 joule. Then loss energy is equal to 1.96. Weight of A is equal to 10,000 and molecular weight of B is equal to 20,000 and molecular weight of the C is equal to 30,000 gram per mole. So in question number 17, given that all component contain equal molecules, that means the molecules of the A is equal to molecules of the B is equal to molecules of C is equal to N naught. So the mole fraction now the weight average molecular weight of the polymer is given by MW is equal to summation of Ni into Mi square divided by summation of Ni into Mi. So where Ni is equal to mole of the component, mole या molecules of component, and Mi is equal to molecular weight of component, individual component. So जो कि N naught into 10,000 square plus N naught into 20,000 square plus N naught into 30,000 square divided by N naught into 10,000 plus 20,000 plus 30,000. Then you get, after the calculation, you get the weight of the molecular weight of the polymer is equal to 2.33 into 10 power 4 gram per mole. And question number 18. In question number 18, given that mixture contain equal masses. Mixture contain equal masses. Equal masses. That means the weight of A must be equal to weight of B is equal to weight of C. So now calculate the weight fraction of component A. Component A and WA is equal to weight of A divided by weight of A plus weight of B plus weight of C. Then is equal to omega naught divided by 3 times of omega naught is equal to 1 by 3. Similarly, weight fraction of component B is equal to A is equal to B is equal to C is equal to 1 by 3. Okay. Now number average molecular weight of polymer is equal to Mn given by in the term of the weight fraction 1 upon summation of Wi into Mi, where Wi is weight fraction, and Mi is molecular weight of the individual component. So 1 upon 1 by 3 into 10,000 plus 1 by 3 into 20,000 plus 1 by 3 into 30,000. Then you get the number of molecular weight is equal to Mn. Mn is equal to, you get Mn is equal to 3 into 10 power 4 divided by 1 plus 1 by 2 plus 1 by 3 is equal to 1.63 9 into 10 power 4 gram per mole, approximately 1.64 into 10 power 4 gram per mole. This is the answer, option A. Common data given that the stress relaxation equation sigma is equal to sigma naught into e की power minus t upon tau naught, where tau naught is equal to stress relaxation time and t is equal to time. So in question number 19 given that initial stress is equal to 2 megapascal and stress after time t is equal to 1 megapascal and stress time, the stress relation time is equal to 60 days. Then now calculate the time required using this equation, stress relaxation equation. Sigma is equal to sigma naught into e की power minus t divided by t naught, where sigma given that 1 megapascal is equal to 2 megapascal e की power minus t divided by 60. Then 1 by 2 is equal to e की power t divided by 60. Then we taken ln 1 by 2 is equal to t divided minus t divided by 60. Then simply t is equal to 60 into ln 2. Then t is equal to 41.58 days. Then option number B correct. In question number 20, given that stress relaxation time at a temperature T1 is equal to 60 days and T1 is equal to 25 plus 273 is equal to 298 Kelvin. And find out the T2 at temperature. T2 is find the relaxation time at temperature 35 degrees centigrade. That means 35 plus 273 is equal to 308 Kelvin. By using the relationship between the Arrhenius equation, by using the Arrhenius equation, the relationship between the temperature and relaxation time is given by 1 upon tau is equal to A naught into e की power minus EA upon RT, where EA is equal to activation energy and R is equal to universal gas constant. Universal gas constant and R is equal to 8.314. Now, then the taking the ratio of the 1 upon T1 is equal to A naught into e की power minus EA upon RT equation 1, and 1 upon T2 is equal to A naught is equal to E upon RT2. Taking the ratio of the equation 1 and 2, you get 11 T1 upon tau 1 upon tau 2 is equal to EA upon R into 1 upon T1 minus 1 upon T2. Remember this formula. Then putting all the values, given the value, and then ln T1 upon T2 is equal to, given the activation energy is given in the question, 30 kilojoule, thus power 3. R is equal to 8.314 into 1 upon T1 is equal to 298 Kelvin minus 1 upon 308 Kelvin. After solving this equation, you get T2 is equal to 0.3931. After solving this equation, you get L1 upon T1 upon tau 1 upon tau 2 divided by after solving this equation, you get L1 tau 1 upon tau 2 is equal to 0.3931. Then you get tau 1 upon tau 2 is equal to e की power 0.3931. Then tau 2 is equal to tau 1 is given that 60 days divided by e की power 0.3931. Then you get tau 2 is equal to approximately 40.5 days. Gauge length of the polymer compound, given that gauge length of polymer composite L0 is equal to 4 centimeter, and cross section area of the polymer composite A0 is equal to 0.8 into 0.3 is equal to 0.24 centimeter square cross sectional area. And change in the length at the breaking point delta L is equal to 0.3 centimeter. And breaking load, the load applied at the breaking point P is equal to 50 kg. Now in question number 21, the sigma acting under this point is known as the tensile strength. Then the tensile strength is equal to tensile strength sigma is equal to force at elastic point divided by original cross sectional area. Then tensile strength sigma is equal to force given 50 kg divided by original cross sectional area is equal to 0.24 centimeter square. Then you get 208.3 kg per centimeter square. This is the tensile strength. Then option number B correct. In question number 22, simply asks young modulus. The young modulus E is equal to stress divided by strain. Then E is equal to stress divided by force divided by original cross section area into strain, change in the length divided by original length. So Young modulus is equal to F into L naught divided by original cross sectional area into change in length. F given that 50 kg into L naught given that 4 centimeter, and original cross sectional area is equal to 0.24 and change in length is equal to 0.03. After calculating it, you get 2.777.77 kg per centimeter square. Then the Young modulus is equal to 2.77 into 10 power 4 kg per centimeter square.